Okay, we're going to take a look at conditional probability, and we're specifically going to look at conditional probability formula. We've dealt with conditional probability through tables. Now we're going to take a look because we're going to may need to use this formula in some of the questions in the assessment. And here it is. Given two events, A and B, the probability of A given B. Of A given B. Given or if, these are words about conditional probability, and sometimes it's just a lot easier to use the formula. The given part is always the bottom part, the denominator of the formula. So again, how is it read? The probability of A given B. Now you'll look at how you actually calculate the formula. You actually calculate it by using the probability of A and B divided by the probability of B. Now we're going to build around something that we already know, probabilities that we're comfortable with and familiar with, and then we're going to build on that just to quickly see how this formula comes about. So something easy, like out of 184 students at a school, 336 have a driver's license. So we want to know what the probability that they have a license is, and it's very easy that we all know that it's going to be 40%, 336 out of 840. Now, if the randomly selected student was known to be year 10, would the probability still be 40%? So we need more information. So we're going to take a look at a little bit more information. So here's the contingency table with more information and where we can build our conditional probability around. The probability the student has a license is 40%. Okay. Now, what's the probability the year 10 student has a driver's license? So we'll take a look at a year 10 student and just a year 10 student. So we're now looking at a much reduced sample from the 840. Remember, it was 840 was the total. But now we're only dealing with year 10s. And so we have 180 year 10s. And so the number of year 10s with a license, there it is, 21 out of 180. Right? So this is, again, probability that we know. We're comfortable with this. We've dealt with this before. Now again, I'm just going to try to build around this formula that I showed you at the very beginning and how it comes out of this table. So if we take a look, we're dealing with year 10s that have a license. So we know it's 21 out of 180. The number of year 10s, or the probability of year 10s, 180 out of 840. Okay, that's not a problem. We know that. Probability that a student has a license, 336 out of 840. That's not a problem. And then from the contingency table, we know that if I asked you, you chose a student at random, what is the probability that they have a license and are year 10? 21 out of 840. 21 students out of 840 are year 10 with a license. Now, let's just take a look at how this sort of goes into the formula. But didn't we say that the conditional probability was the 21 out of 180? And that's exactly right. This is the actual answer, the 21 out of the 180. So we've got probability that they're year 10, probability that they have a license, and the probability that they're a year 10 with a license. So look at how this translates into the formula. 21 out of 840, that is the probability that a student has a license and is a year 10. And you divide that by given that they are a year 10 student. 180 out of 840. And when you do that division, this is what you get. So you see the formula works according to what we've already done. And finally, let's just look at another example just to try to consolidate this. We have some information about a tramper. If a tramper, and there's 40 trampers chosen at random, okay, if a tramper chosen at random is a visitor, what is the probability they are female? So you could say this is if the tramper is chosen at random, okay, and you've got to think about what is the given part of this? What is the given that they are a visitor? What is the probability they are female? So they haven't used the word here. But in fact, given is implied. Hopefully given will be said to you. But if it's not, you take a look at how the sentence is worded. The probability that you're trying to find is that they're a female. Given that a person chosen at random is a visitor. All right? So this is the scenario. The probability that someone is a female tramper given that they are a visitor. And the given that they are a visitor goes on the bottom. So this is what it looks like. So, the very first part of this formula, you have to work out the probability that they're female and a visitor, 9 out of the total 40. And then that given that they are a visitor. So how many visitors are there? There's 30 out of the 40. And that gives you 3/10. And that's how the formula works.